Previously, I was talking about the relationship between x and y is linear in the sense that the slope of the line, it remained constant. But sometimes we are interested in showing a relationship between x and y in such a case that either y is increasing at an increasing rate because of change in x, or y is increasing but at a decreasing rate because of change in x. And similarly, you can apply the same concept to show the relationship between x and y, that is when y decreases at an increasing rate or decreases at a decreasing rate. So you can show these relationships. And we show these type of relationships using a quadratic function. And these type of functions are used frequently in econometrics. So see here now, in contrast to our previous interpretation of this beta 1, where it was showing the change in y when x changes by 1 unit, keeping all other variables constant, we cannot use the same interpretation in this case because it makes no sense to change x here but keep x fixed in this case. So our interpretation is a little bit different. Now, change in y, which is caused by 1 unit change in x, itself depends on x. And typically, we might plug in an average value of x in the sample here to make this result interesting, or we can use some other values. Okay, in this first example, we are interested in relationship between wage and experience, and we believe that as the experience increases, it may have different returns to wages depending on experience itself. So I'm gonna go ahead and progress this equation, and we got these two values. The change in wage due to change in experience is a function of experience itself. So what we can do is we can plug in different values of experience to know more about the impact of change in experience on wages. For example, if experience equals 1, that is 1 year of experience, we would expect 28.6 cents more wages. Similarly, when experience is 10, we can show that the increase is 0.178 or 17.8 cents, right? So as you gain more and more experience, extra experience is not adding a lot in your salary. In this case, returns to experience itself depends on experience itself. In the second example, I'm going to show you price as a function of rooms and rooms squared. So my equation is, I'm interested in log of, let's call price equals beta 0 plus beta 1 rooms plus beta 2 rooms squared plus some other factors. So we can see that percent change in price due to 1 unit change in room, it depends on the number of rooms already in the house. So we can plug in different values, and I'm going to plug in 5 rooms here and get about 7.5%. So if a house has 5 rooms, then the change in the number of bedrooms from 5 to 6 rooms will add to the house price by 7.5%. So the house price will be 7.5% more as compared with a 5-room house. Similarly, we can plug in other values to know more about this. One thing to note here is that if we plug in a value of room less than 4, we will get negative effect on the house prices. That is, if we change the room size from 3 to 4, then the house price will decrease. Now this effect is very counterintuitive, because normally whenever we add another room in the house price goes up rather than goes down. One reason of this negative effect could be our sample. We have very few houses in the sample with rooms less than 4. That is why we are getting this negative result. So whenever you regress a model like this, pay attention to your sample, and knowing more about your sample will help you understand these results better. We can also extend the quadratic function to include other polynomials. So it may fit our data a little bit better, but the interpretation is hard for this type of models. That is why most of the times these quadratic functions are used, because their interpretation is a little bit easier as compared with polynomial or higher order equations. In the next video, I'm going to talk about the interaction terms. All right, see you in the next video. Bye bye.